I'm gonna make this diagram. As you can see, it's from mechanics rotation. So in this diagram, as you can see, it's a beige, solid beige, but we can represent using triangle. And then after a spherical body is placed on the set on the beige, and on the spherical body there are two forces acting on it at r distance, like that. And yeah, that's it. So let's get started. So firstly, we have to do some kind of like observational thing to draw like in a planned manner. So as you can see, if you are thinking first we have to make this triangle, then after we have to make this circle and then arrow, that's wrong. Yeah, that's possible, but I think that is much complicated. So first we have to do is like draw this part on a plane, like horizontal plane, like hypotenuse, and on this hypotenuse there is a circle and these forces, and then we have to rotate all these component with respect to this point, or we can just define this point at or as origin. So this is how we can draw this diagram easily. So yeah, let's get started. So as you can see, I have made this diagram already, but I'm gonna make from the scratch, so don't worry. Just comment these lines and start with the center environment, then after nest within the center environment, that is Tikz environment, and let's get started. So firstly we have to define few parameters. So in this diagram, as you can see, there are multiple things. Firstly, radius of the circle. So inside the Tikz, we are going to define some variables, and for defining variables we start with using the command called def, and def is the shortcut for the definition. So you can let's give few examples. Python will be, I think, no, Swift. No, Swift. Swift rep. Swift REPL. I should have a yeah. So as you can see, we are now in the Swift interpreter, you can say. So let's define a variable. So for defining a variable, we just call var for variable, name of the variable, then we just put the value, right? And second variable, let's var maybe b is equals to like 7. So where is wrong? Var b is equals to 7. Yes. So we defined like a two variable a and b, and now we can add this a and b, as you can see, 12. So in this line we are defining, like creating new variables called b and putting the value 7. So this is kind of similar way we are going to define variables inside the Tikz. So def is the command for that, and then after again we have to name the variable. So for again naming, we use the backslash, and then after we can use capital R. Capital R is here for the radius of this sphere, or you can say circle, and then after you can put the value within the curly braces. So let's for right now we can say 1 is the radius of this circle, and then we have to define this angle, like how much we want the rotation. So for that again we have to define, and we call it a is for the angle of rotation, and let's say for right now it's 30. We're gonna use a little bit later. and we can also comment this line for the reference. So this is radius of a sphere or circle, you can circle say circle, and this is the angle of rotation, or I can say angle of beige. So these two variables are defined. Now we are going to define a coordinate. So let's say this coordinate as capital O, which is the origin. So you know already, for defining coordinate, just we have to use the command coordinate, name the coordinate capital O, insert the small bracket, and then after put the coordinate. So we have defined three things, two variables and one coordinate. And let's say a few more things. So we have to define a coordinate. We are going to define this coordinate, or we should reference this geometry, exactly both are same. So this coordinate, let's call it B. So let's call it B. One second, yes, capital V, and we want this like -5. But hold a second, like we also want like to define this coordinate as well. So firstly, let's define this coordinate. So 5, and there is a problem here, like if we want like this to be 5 unit, so this have to be like 5 cos theta, right? So let's say we are going to call this as the 5 unit, like length of the hypotenuse, or you can just define also that, like let's define length of the hypotenuse. So define, let's put capital H for hypotenuse, right? And for that we are going to use the 5 unit. So for that we are going to use H, because hypotenuse is of 5 unit, that means ki base would be H times cos of theta. So cos of theta, and theta is capital A, so we are referencing the capital A, and because B will remain always at the base, that's why bicoordinate will be 0. So we just define two coordinate O and B, and from here we just have to keep going. So now we can use a scope. A scope is like is a group of, you can say function, or just group of commands. So if we want something to rotate, like we want this circle and hypotenuse to be rotated, so we can put that circle and hypotenuse inside the scope, and we can put a special commands for the scope, so that whole section within the scope will be rotated or translated like that. So let's say rotate, for rotation, rotate around is a command. Rotate around is equals to, then after we just have to put the coordinate, firstly angle, so angle, and then after coordinate. This means that every command within the scope will get rotated by angle A about the coordinate O. So angle A is 30 degree and coordinate O is this origin. So let's start drawing. So firstly within the scope we have to define the coordinate, of course, which we call A. So let's define coordinate. So coordinate A, and this we call as like minus hypotenuse, because we are moving like towards left side, and then pi coordinate 0. So if we render this, you can see only a hypotenuse and nothing else. Where it's wrong, man? Let's see this reference. No, everything is fine. Let's minus put, because we are rotating in the opposite direction. Nothing is wrong. Where's problem? Line 156. So let's firstly comment this out, then have to run. This is the problem. You have to like run in every line, so that you just like make sure that you are writing the good code. But don't worry, we can fix it. Oh yeah, there is like a missing of a square bracket for this optional thing for the scope. So yeah, as you can see, I think there is nothing. What's the problem? Oh, sorry. We have drawn, actually, as you can see, we have drawn nothing, just defined a coordinate. So now is the time to draw something. So draw, firstly we want a line, so from O to A, and this line is hypotenuse, so you will see a hypotenuse. So as you can see, it's a hypotenuse, and for the whole diagram just we can use a scale is equals to 1.5 maybe, so that it will just make larger. Yeah, so as you can see, it's just a hypotenuse, and we can also use maybe very thick is the line breadth. It's just a keyword styling thing. So yeah, as you can see, hypotenuse is drawn, and now like as you can see, we just defined the coordinate A as the minus h comma 0. That means it should be on the h, but it's, as you can see, it's rotated about this origin with the angle of 30 degree. That's why it's joining the line and feels like it's hypotenuse. And next we are gonna draw a circle. So draw, and where we want the center of the circle, so we just have to calculate things. So for calculation, as you can see, we want like from O, then after we want to move from O like -3 unit, and along the Y we want to move for the radius. As you can see, we just grab this coordinate point O, and from there we want to move -3 unit left, and then our radius unit along the y-axis, and then whole thing will get rotated. That's why it will just draw on this hypotenuse. So draw, or you can just define another coordinate. That will be, I think, much better. So let's say we're gonna call this center of the circle, that's why CC, and just copy whole thing, Command C and just Command V, and this will CC will be the center. So now just reference CC is the center of the circle. Now circle, and then you can put radius. The radius is equals to, as you know already, capital R is the radius of the circle. And if we render this code, you're gonna see a circle on this hypotenuse. So yeah, as you can see, it's a perfectly drawn perfectly drawn circle with radius 1 unit. So let's remove this part firstly. So rotating thing has been removed, and now you will observe that it will just shift to horizontal, as you can see. So in reality, we are making all these diagrams in the x-axis, or you can say in the horizontal plane, but just we are doing the rotation thing. That's why it's appearing on the hypotenuse, or you can say on the base, as you can see. So for right now, just hide this thing, because this way I think thinking is much simpler. So yeah, a scope is doing nothing here, just grouping the command. And now we have to draw this like arrow thing. So how you going to draw arrow? So for arrow, we have to use the angle like polar coordinate. So as you can see, from the center, like for the center, we can do one more thing. Fill the center, like fill CC circle of 1 point. That means it will just like represent a dot at the center. So as you can see, here center. So we want force to be like that, an arrow thing, and from the center we want at 45 degree, or in the opposite direction we also want at 45. But you can see it's 180 plus 45, that means 225. So, or you can just reference the angle. So we just have to define one more variable, def, and this time we're going to call a small a, and we call it 45 degree. A small a is the angle for force with respect to center of the circle. So as you can see, we have defined an angle. Now just we have to define two coordinates. So let's call it right arc. So at this point we're going to define a coordinate point. We call it right arc, RA, and we're going to define like angle. So angle is small a, then after radius. So already you know radius, because we are going to moving the point on the circle, that's why we are going to use capital R, that means radius of the circle. And one more coordinate we're going to define, we call this left arc. So this part, this point we call LA, and for that we're gonna say 180, sorry, 180 plus a, that means ki it will just make 225 degree. So we have 2 point on the arc, and where it's gone, and from now we just have to make 2 arrow. So for arrow, just draw, and you can arrow thing, and what we want, like arrow will be in opposite direction because we are starting from this point. So what we want like from the RA, like this point and a horizontal line. So for that we have to use relative coordinate. So we want along the x-axis positive direction, that's why we have to use +1 by coordinate 0, that's why just 1, 0, and from there we just use for the left as well. So left arc, but from here we want to move towards negative x-axis, that's why we have to put -1, 0. Where's gone, man? Yeah, something is wrong. 180 plus a, like what's the problem? What is the problem? What is the problem? Let's check this first. Like for that we can just use fill command, fill or a circle, and a circle of 2 point. We are just checking where is RA and LA. So yeah, RA is wrong. What's the matter? Oh yeah, man. As you can see, we defined RA and LA wrong way, because as you can see we put the absolute coordinate, we have to calculate, right? Because A means like angle, as you can see it's made but with respect to origin. So first we have to calculate thing. So yeah, we did something blunder. So we have to yeah, as you can see we have to define with respect to with respect to center of the circle. So center, and with respect to center we are moving all these things. So yeah, I think you got it now. So I did something blunder. So now it's, I think, okay. As you can see we define RA but with respect to this point, right? So we have to move with respect to center of the circle. So CC plus the new coordinate which will move for, let's check it first. So as you can see it's perfectly drawn, as you can see, as we expected. But previously if we just use angle A and colon R, that means it will just define the coordinate with respect to origin. But we have to like define again for which coordinate with respect to we are gonna define. So here we're gonna define with respect to center of the circle, that's why we have to calculate things here. So yeah, it's, I think, better now. And one more thing we have to do is we have to use like dashed thing. So for that we're going to draw some like arrow not dashed line. So dashed inside the square bracket, because it's optional thing. We are going to make this line, actually these two lines. So for line we are just to start with the origin, sorry, center of the circle, and then after from here we wanna move like a relative coordinate we are using here. So we wanna move like upwards. So as you can see, if we use r as the hypotenuse and this as the base and this is the perpendicular, so and this is the angle, so hypotenuse times cos will be this, hypotenuse times sine will be this. So hypotenuse, which is capital S, and the sine of the angle, and angle is just smaller because we are referencing this angle with respect to the center. So yeah, this is the y coordinate actually, and x coordinate will be 0. That means ki from this point we are gonna make a line, but we just have to move upward like that. So that's why we put it x coordinate 0 and we put it y coordinate. So if we just render this, you will see a dashed line from center to some upward point. Oh man, what we did wrong. Oof. What is, oh sorry, we used relative. No, relative is good. What is the, oh sorry, or radius we have to use, not hypotenuse. Hypotenuse we use, that means this line. So yeah, we have to use capital R. Yeah, perfect. And from now just we can use absolute coordinate, because we know already this coordinate for call RA, right arc. So it will just make a horizontal dashed line and it will look like a perfect representation. So yeah, it's perfect. And we can do this for the downward part as well. So here from CC we want exactly same but negative, and then after left arc, so we just have to change 2 parameters. So yeah, it's perfect. And it's time to node things out. So we want like here the r thing. As you can see in the diagram, r is the radius at which not, you can say radius as the distance actually. So we want node in between these two coordinates, so center and this upper coordinate, in between we want node. So that's why we putting after these two coordinates and before the final coordinate. It's important. So we are going to put a node and we want midway and left. Midway means we want like somewhere in the middle, and left means middle. Then after shift that node to left, or depend on how you define. And then after you can put inside the curly braces the node which is a small r for right now. So yeah, smaller. And we can do this for the lower part as well. And this time we can say right will be better, I think. Space doesn't matter, you can just use the space for better readability. So yeah, it's perfect now. If we just turn on this rotation thing, you can see the perfect diagram on this hypotenuse. So I think most of the part has been done, and we just have to define few things. So yeah, now we have to move outside the scope, because rotation thing is done, or you can say for the scope everything we have done is perfectly right. Now we just have to make this angle, and we just have to join these two lines. So draw. Now one special point here, you have to get out of the scope, because scope we are using for the rotation. So you don't have to rotate this base and perpendicular. So get out of the scope, and from now on just we have to join this origin. Then from here we are gonna join B. So B, and from there we are gonna join A. A is this upper point, and just have to stop. So it will make a like two lines, you can say. So as you can see, it's perfect. And one last point is just we have to use this angle, like you can. So for angle kind of I'm gonna use TZ package, as you already know. Sorry, TZ plot package. TZ plot is basically a superset, not you can subset of Tikz, because it's just a syntactic sugar, you can say. It just combined multiple syntax in a much simpler way. So for that we can use TZ angle mark. TZ angle mark is the command for drawing angle, and for angle we can just give 3 coordinate like A, O, P. So in between it will make angle. So let's start with A, O, and then B, and it will draw angle, and then it will put just node. So for node we can use theta. As you can see inside the TZ plot, you do not have to put semicolon like that, but inside the text you always have to put semicolon for the end of the line. So yeah, it just defined in a way, such a way that you have to write a smaller amount of code. What's wrong in that, man? Oh, where is A? TZ angle mark, we did right, but let's theta, O, and B. What's the problem? Let's say dash. No, TZ ANGLEM, like exactly that. TZ angle mark. Oh, sorry, we put it like a dash. Oh man. So yeah, just you have to put 3 coordinate, nothing else. Oh yeah, as you can see, perfectly drawn angle is represented. And I'm gonna pick point few more thing. As you can see, when we join line, it just do not joins perfectly. As you can see, it's like a error kind of thing, and in the arrow thing you also see it's not looks perfect. So for that we are gonna use for the whole thing, which is cap of the line is equals to round. And one more thing, I'm gonna use arrow will be latex arrow, like this thing. As you can see, for right now it's stealth. Yeah, stealth is great, but I like much better like latex. So yeah, as you can see, now the joining part is great, and line ending is also round, like perfectly rounded, and the arrow thing is also looking great. So yeah, this is how you can like pick point a small thing and manipulate. And the magic thing is now, as you can see, sphere is proportionally very large, so just we have to reduce the radius and it will draw perfectly, and it will calculate every coordinate accordingly. It will settle down. As you can see, it's just a smaller sphere, and it's look perfect. And just you can change angle, still it will look like nice. So that's why we have to have define and use variables for this kind of diagram, so that we can change any part at any time without messing the whole diagram. So yeah, as you can see, it's looking great. Even you can change the hypotenuse, like if you want longer hypotenuse, so let's say 7. So yeah, as you can see, everything fits perfectly. And even you can define one more variable. As you can see, we have hard coded the center of the circle as -3. So you can define in the middle, like midpoint of the A and the what you can say, yeah, let's fix the center we want in the middle. So for that, like for calculate the midpoint, so 0.5 means it will just calculate the midpoint, and So in this part we have calculated the midpoint, and again we put a dollar sign. one thing I have to do. Yeah, again put $. So as you can see, firstly look next to dollar. So this coordinate will calculate a midpoint between O and A. So yeah, I think here is completed, and from now we are gonna move. We do not have to move X, just move to Y. So that's why we are just put it the shifted second coordinate, which is 0 comma R, you consider it is. That's why it just shifted upper. And if we run this code, you're gonna see perfectly center. We'll see a circle at the center. So yeah, as you can see, we have fixed this coordinate. You can get confused in this part because yeah, it's complicated a little bit, but I'm gonna explain one more time. So as you can see, this is the coordinate we calculated, and using this coordinate we again doing calculation. So we are doing two things here. Firstly calculating midpoint between A and O, and then after shifting this midpoint upper with the help of radius, and this is exactly the same. So now we can just change the hypotenuse. It will stay in the middle. So as you can see, it's perfectly fine. 7 looks better, I think. So yeah, this is how you should plan a diagram and try to make it. So you have to get an idea about variables, memory, about the programming languages, and from there you can apply the concept in this part, like Tikz part. I know Tikz is much easier than any programming language like Swift or Python or any other, but kind of conceptually it's the same. Like you just use memory, you just use variables, you just use formula like algorithm, function, like that. So kind of it's a programming language, but you can say is the most basic programming language. It's like most easiest one. So if you learn some programming language like Python or Swift, or like Swift is a statically typed language, so it's kind of difficult to grasp at first, but you can start with Python, and you can apply the same concept over the Tikz or any kind of other thing. So yeah, I think it's kind of a long video. So yeah, you have learned a lot, I think, in this tutorial. So yeah, thank you, and see you in the next tutorial.